Okay, good afternoon. Welcome everyone. Very good that you're all here despite the nice weather and the late time of the day, etc. What I'm going to talk about, and first let me introduce myself. I'm Ewout Prangsma. You can find my Twitter account there as well. I work for ArangoDB. I work in the cluster team in ArangoDB, and the cluster team is everything to do obviously with cluster, but also everything on top of cluster, and that is the thing that I'm going to talk to you about today. So I fear that the text is a little bit small for in the back, but I'm just going to talk to you what I'm going to talk about first. I am going to give you a very short introduction into ArangoDB. Just some show of hands, who knows ArangoDB? Who has played with ArangoDB? Okay, some, good. I'm not going to go really deep into the database itself. I'm really going to go into what we do on top of the database, and more particular in case of very large enterprise uses of it with data center replication. And the second part of the presentation is going to be about how to deploy in an orchestrated manner, in this case with Kubernetes, and what we did for that. And hopefully if time and all the Wi-Fi gods permit, then we can do some demo and bring everything together. Good. A very short introduction into ArangoDB. If you want to know more about ArangoDB, go to the website, go to the marketing team at the booth there. They can tell you everything about it. Just some highlights. It is a multi-model database. What does that mean? That means that there are no SQL documents, that there are graphs, there are key value stores, and everything is in a single data engine. So the storage engine is used for everything. And you can also use a single query language to cover everything. So you don't have the need to have your documents in database A and your graphs in database C, B, and with all the negative side effects that you have from that, it is just all in one, and you can share all your operational knowledge and all your backup cost and all that stuff in one thing. Well, there are some nice statistics. I'm pretty sure that by the time of this presentation now the statistics are already outdated because we are changing rapidly. We have a lot of downloads, a lot of contributors, and at least for the most part we are open source. We do have an enterprise version. If you want to play around with that, just register on the database on the website, and you can download the enterprise version as well. And of course, the marketing team is then going to contact you, but don't worry, they're friendly. By the way, you will need that if you want to replicate what I'm trying to show you today. So have some fun with that. Good. Traditionally, some slides to just show you what ArangoDB is about and what is this multi-model about. Traditionally, you have either relational databases, or you have graphs, or you have time series, and for everything you have your separate tool with separate knowledge, separate backups, separate people, and what have you. And to be honest, that's a pain in the ass, because it's not necessary. And the reason it's not necessary that in ArangoDB we combine all these models in one, and you can just enjoy the fruits of that, and make it a lot easier. You can, again, in a single query language, capture all your data. And the beauty of it is if you start out with, for example, JSON documents, which pretty much everyone starts out with, and you later on decide, hey, I'm also doing something relational, just add some graphs and find the information a lot quicker in that way. So you can use all these models. It's no problem whatsoever. You don't have to install anything else. It's just all in the same package. There we go. So this is about making complexity easier, just skipping around and saying, well, do everything in ArangoDB and you're pretty much done with. So some view of how this looks like. You can see on the left your traditional SQL. We don't use that. We use what we call AQL on the right. It's pretty similar. It's very human readable. And again, in a single query, you can create stuff, you can query for data, you can pretty much do whatever over all these different models. Good. So far, the introduction into the ArangoDB. So for those of you who are already asleep, now it's the time to wake up again. I'm going to go through a couple of stages that ArangoDB has gone through over the last couple of years. And in the recent years, ArangoDB is attracting a lot of enterprise customers. And what does that mean? That means that your single machine database doesn't cut it anymore. You really need to go for clusters, for high availability, for more data, and all kinds of different reasons. Machine failure is also a very important one. So over the last couple of years, we added the cluster mode of the database. That means that you can pretty much spread out the data over a lot of machines, scale easily. If you need more querying power, then you add a couple of servers to do that. If you need more data, then you add a couple of servers with large SSDs, whatever you want to do. And that lives in the cluster. And just, I'm not going to give here a very big talk about the cluster itself, but just to give you an impression, in order to make this cluster work, we have 3 different types of servers that you will be running. They are all running in the same binary, so that's easy, but they're running in different modes, and we'll see that later on when we also come back to Kubernetes. And that is, first of all, every data in your collection is sharded, and these shards are spread out over what we call DB servers. And DB servers is one of these 3 types of servers. The other ones are either agents, that are really the hardcore state of your cluster, and the other one is the coordinators, and that's where you send your requests to. And they coordinate the data, and they make the queries happen, and a very nice side effect of that is that you can also run very small JavaScript applications on your coordinator, so then your at least a significant initial part of your business logic can live literally inside your database. And that is a very powerful mechanism. Good. But now we have this cluster, and what happened last year? Because last year, a couple of things really started happening that, first of all, made this talk possible. That's, of course, the most important one. But for ArangoDB, it was also really pleasant to get a lot of customers that are really enterprise, but not only enterprise, but enterprise at a global scale. And that is bringing in some new challenges. And first of all, it was the realization, okay, apparently our ArangoDB cluster offering has grown up. Of course, every time you start with something as complex as a distributed system, which a cluster is, initially you have some challenges. Let's call them bugs, but you can call them challenges. And over the last couple of years, we really kicked out most of them. And now this thing of cluster has grown up, and then suddenly customers start coming to us and saying, well, this is very nice, but I have my cluster here in, let's say, New York, and I have another cluster in India, and I have a second cluster in New Zealand, and yeah, now what? I want to have access to the same data in all 3 different places. And we were like, okay, let's think about that a little bit, and we started asking, okay, why do you want to do that? Well, and we came up with some, or the customers came up with some very reasonable answers. And it was all about geographic availability. It was about disaster recovery in case of really big disasters, like your entire data center bursts down or something like that. And also for functional reasons. Just, I'm running an application, and the application is split up over data centers all over the world, and I need my data for this application part here, and this, etc., etc. So we ended up with, okay, so apparently we now have clusters, and cluster itself isn't good enough anymore. We need to go across the cluster. So that was just an additional layer, and thank you to our customers, because the very first thing that they also said, well, a little bit of latency is acceptable. And we were like, phew, because we were already thinking like, how the heck are we going to do that if we want to do something, distribute something all over the world and then still have good performance? So that was a very good thing. So what we did is we came up with the concept of data center to data center replication. And that concept was born in the summer of 2017. And we quickly identified a lead customer to help us develop that feature. And now I'm going to the talk further going into, okay, what did we actually build and why and how, and what did we have in place to do it, and why did we do it as we did. And one constraint was very clear from day one, and that is, yes, we need this feature, yes, we need it on budget, yes, we need it high quality, but most important, it has to be there as soon as possible. So at least that was clear where the priorities were. So I'm not saying that we screwed around, but we've taken slightly more time than planned, but I'll come back on that later. So what we ended up with is a set of requirements. And that set of requirements was basically, we want to synchronize data from one cluster to another, and with the data, I mean all data. So metadata about the structure, about who is allowed to access it, which collections do we have, which indexes, as well as, obviously, the data itself. Also important, we don't want to delay local writes. So that's where we came up with, okay, let's do asynchronous replication, because as soon as we start doing it synchronously, that's not going to work it anymore. It had to be ready for testing at the customer by October. And by the way, we invented this probably somewhere in July. So it was like, okay, crap, we still have to go on holiday and then have to do this, so let's have fun. So then you first decide, okay, what do we have? What can we build this with? And then a couple of things came about that, okay, this is what we have. We have a shard synchronization protocol, which basically means I have a shard here and I have a shard there, and I can very efficiently replicate the data between, and in such a way that it only replicates diffs and not transfers more data than it really has to. We also had drivers for the database in lots of languages. And we had a very large C++ code base. You have to keep in mind here that ArangoDB itself, the database, is written in C++, and most of my colleagues are hardcore C++ developers. I'm not. So that was already interesting. And we also had a very small Go code base. And I'm programming a lot of languages, but nowadays mostly Go. And we had probably 2 developers that were at least have some experience, and I was probably the one with the most experience. So we had a discussion like, okay, what do we have to do? And we ended up with, at some point at decision time, after a lot of discussion, how are we going to implement this? We said, well, a lot of people know here know C++, but let's be honest, we are never going to make October 2017 if we want to do this in C++. Now I know that I'm probably going to offend a couple of people here by saying that, but that is purely based on our internal statistics and not yours, so don't be offended of that. And although Go was a lot less known within the company and we had a lot less experience with it, it seemed to be very suitable for an application like this, where it's all about getting traffic over the network, doing that in a secure manner, etc., etc. And of course, we also had the option, maybe something else. But that one was easily discarded as, let's not try to invent something new here now. So we ended up with 2018 in mind. Okay, 2018 is coming up. What is that all going to be about? It's going to be about security. So we decided to do TLS all the way. So encrypt every network traffic. We don't even give you the option to do it without. Let's authenticate everything. And I mean everything. And that's sometimes a bit annoying for customers if they want to do something quickly, but it is just about, okay, we are sending sensitive data over the internet potentially, so let's try to be as safe as we have to be in the year 2018. And given our ArangoDB experience with supporting TLS in C++, we said, okay, this is the decisive factor, let's do it in Go, because we know it's going to be a walk in the park in Go compared to something a little bit more awkward in C++. So we decided to go for, let's go for a binary that we write in Go, and the initial design was literally on a piece of paper that looked something like this. We said, okay, we have a data center on the left, we have a data center on the right, both have an ArangoDB cluster. We're not going to change anything to that cluster, we hoped. And then we are going to have Arango Sync, and Arango Sync is this new binary that we were building. And Arango Sync is going to control all this data flow, and we said, well, let's be smart and try to find a tool that we can use to actually do the heavy lifting of the data across the internet. Because we were a bit afraid of that, and we said, okay, let's use a message queue for that, and Kafka was the obvious solution to do that. So we have some control messages between the Arango Sync on both sides of the both data centers, and we have bulk data, so the actual data that we want to transfer through Kafka. And obviously this picture has changed a bit over time, but in a way it's still there. So what did we build DC to DC, which is short for data center to data center? What did we build it of? Of course, the ArangoDB cluster, I already mentioned that. We really hope that we did not need changes there. Unfortunately, that was not completely the case. We had an Arango Sync. We had a all-Go standalone binary. And standalone, in this case, also means statically compiled, easily movable from one Linux distribution to the next and things like that. And this Arango Sync implements two roles. It implements a master role and it implements a worker role. And the master role is really about controlling this entire application, and the worker is about, okay, apparently the master has decided that some work has to be done, so somebody has to do it, so let's do the worker, let's do that. And we had Kafka, and with Kafka you also get Zookeeper as a distributed key value store as a, let's say, bonus. And that was the message queue. There's also a buffer for downtime. And you can imagine that if you start replicating things across data centers between, let's say, New York and India, you are guaranteed to have downtime on your network link. You cannot just say, well, I'm just going to wait for a couple of seconds and then expect it to be there. No, this can literally take an hour. And for computers, an hour is obviously a very long time. So we had to buffer our data in some point. Very short overview of the development team. It was just very short, very small. Easily concluded, and later on it grew a little bit. But I think the most important partner in the development team was actually our lead customer. Not initially. We had a lot of discussions initially between ourselves, and then the lead customer came in and we learned a lot, but especially as soon as we started hitting our lead customer with some test versions, it proved to be absolutely, well, sometimes painful, but very, very, very useful. So, what were the challenges that we had? Obviously time pressure. It was just a very short time, and it was made very clear, like, this is a very important project and it has to succeed no matter what. Okay, so let's do that. And then remember that I said we hoped that we didn't have to do any changes to our database cluster, but unfortunately we found out that there were some APIs that we needed were actually not there yet. It was not that difficult to add, but as you can imagine, in something as complex as a cluster database, adding a feature like that is a cycle, and that just takes a long time. It has to be developed, it has to be tested, reviewed, etc., only to find out that you're missing something else again. And we also had some challenges for automated testing, because you can go, you can create your unit test fairly easy, But at some point you also have to test the real thing, hopefully automatic, and reproducing failures especially is just very hard. And what we learned is we can come up with some failure scenarios, and then your customer finds other failure scenarios that you didn't even think about. And finally, we had a very big challenge with Kafka and Go. Kafka, as you probably know, is a Java product, and there are lots of very good Java drivers for it. And there are some Go drivers for it, but to be honest, we had problems with pretty much all of them. Initially, we said we want this binary to be an all Go binary. So every driver out there that is not all Go just was moved away from the table right away. But we ended up with a small selection of drivers, and either they were not broad enough API-wise, so they just didn't support everything that we need, or they were not stable enough. And that was a very big problem. So eventually, we had to do something there, and we ended up mixing the two of them. So what did we do to do that? Because in the end we said, okay, the Confluent driver for Go is probably the best one. Unfortunately, we found that out rather late in the process, so it took some time to catch up on that. But the Confluent Go driver is really a wrapper around the C++ driver. And the C++ driver is very well tested and is very stable, etc. But now as soon as you wrap something in Go around it, then you're suddenly stuck with the problem that you're linking to a dynamically linked Kafka client driver in C++. And personally, I was very much against having anything that was dynamically linked. I really wanted to have a single binary knowing all the problems that we had with a database where we did not have statically linked binaries. So we went to very large, into a very large effort to come up with a way to build this thing in such a way that we ended up with a single statically compiled Go binary. And what we did was we made our own build of the Confluent Kafka C++ library using an Alpine Docker image and using the very small libc library that comes with that. And with that, we built a Docker container that we used to build everything together, and we could link the C++ driver with the Go binary into a very statically and, in the end, very big binary. But in all honesty, I didn't care that much about the size of the binary. I was very happy that we were able to get this build actually working as a single static binary. There was one side effect. Now the server part was Linux only, because we already struggled to get everything up and running with all the static compilation for Linux, and we didn't even dare to try it on Windows or the Mac. But we come back on that a little bit later. There are ways for the future. Finally, a couple of things about automated testing. For our testing, we used a lot of small cloud machines, and we use Scaleway for that mostly. A couple of other providers is there as well. And the reason we use small cloud machines is that it is very easy to take a very big AWS machine and then don't find the problems that you have with small amounts of memory. But a small machine means that you find your problems quicker. And of course, you can also take them too small, and then you don't find anything. But choosing the right balance was okay. What we did is we used Ansible for provisioning these machines because we want to have a repeatable cycle where you can easily say, I have a couple of new machines, deploy the cluster on it, deploy the binaries on it, do everything, run some tests, and then drop everything again. Obviously, you need to automate that because we needed 6 machines in all cases because we needed to have a cluster with 3 machines on one side and 3 machines on the other side. So you already end up with 6 machines, and that's just not funny anymore to do that manually. So one conclusion that we have is we did too few unit tests. We should have done more unit tests, and that would have helped, but that's where you learn. And in the end, we ended up splitting up our test because things just took way too much time. And we said, okay, we run a short number of tests for every pull request, which again means having all these 6 machines ready, running some tests and all the stuff. But that all happened in somewhere like 20 minutes or so, and then we knew, okay, at least the basic things are still working, and during the night we run every test that we ever invented. Some points that we took out of it. At some point we found it very hard to find out what is exactly going over this message queue wire, and you have tools for that to inspect it on Kafka. But we wanted to make sure, especially when we had all these problems with the Kafka driver, that are we really sure that things ended up in Kafka? So we added our own trace of messages, and that of course completely blew up our machines in terms of this size, but it proved to be a lifesaver in many points. It can also really help for your logs to synchronize the clocks of your machines. And you would imagine that cloud providers do that automatically for you, but not everyone has read that memo yet. We had in ArangoSync, I think ArangoSync was the first binary in the first product was in ArangoDB that was a heavy user of metrics. It provides a lot of metrics that are Prometheus compatible, and of course you can use Prometheus for tracking the state of your operational system, but for us it also proved to be a very valuable debug tool. Something is going wrong. Let's look at the stats or the metrics for the last 10 minutes and see what's going on, and it helped us a lot. And finally, you can test a lot on your own on-prem machines if you have a lot of big test machines. But you're probably not going to find the problems that you find in the real world with real network connections. So it was fun to test 3 machines in Paris, 3 machines in Amsterdam, or 3 machines in Paris and 3 machines in Vilnius, and just figure out, okay, the internet is apparently not that good, and you really have these issues, and you have to deal with that. So we learned a lot from that. And how did this end? Well, in November, you remember perhaps we said October, but in the end, in November, we kind of made the end of October deadline. But in all honesty, we underestimated our testing effort. And one test that we had a whole lot of problem with, and that was actually invented by our customer, was kill minus stop. He was a very big fan of kill minus stop, and for those who don't know what kill minus stop does, is it basically freezes your process, but still keeps alive all your network ports. So we had all these mechanisms in place to detect that a process on the other side was gone, assuming that the process was really crashed. But in this case, when you stop the process, the network itself doesn't say right away, I'm gone. So you have to have additional timeouts, and it wasn't fun, let's be honest. So we ended up doing a lot more tests and a lot more work, and in the end, on January 5th of this year, we released the final stable version. Well, of course not final, but the very first really stable version that the customer accepted and started to use. Well, this was all fun. What did we learn? First of all, it was a bit complex. And it was complex for the customer, it was complex for us, and it had too many moving parts. One of the big moving parts that we really didn't like was Kafka. We had a lot of problems with Kafka, not only with the driver, but also a customer saying, well, I'm not that familiar with Kafka, and which version do you have? And one of the things that we didn't really count on up front was that this is a very big enterprise customer, and they are very keen on what they run in their data center. So they said, well, which version of Kafka are you running? And we were like, yeah, let's take the latest one. Yeah, well, we can do that, but that means that we have to certify it, and that is a process of at least 4 months. Like, okay, which one did you already certify? Well, it was the previous version. Fortunately, that worked as well. But that was one of the things that we have to deal with, and it was unexpected for us. But it was really a trigger to, let's try something else. And we said, we need to simplify, and what is the easiest, well, not the easiest, what is the biggest thing that we can drop and try to reduce complexity, and that was Kafka. Let's drop Kafka and let's build our own message queue. And of course, that is a very stupid idea and you should never do it. But we did it anyway. And we did it for one good reason, and that was that we learned in this process that although Kafka brings a lot of security in terms of how you transfer your messages, etc., and the guarantees that you have with your delivery, we realized that we don't need that in all cases. Because we already had an entire protocol on top of that, communicating everything and keeping track of messages and making sure that messages were not lost. So our initial problems with the bad Kafka drivers were actually a lifesaver in this part, because we had all this stuff on top of that that already corrected that. And we ended up with, okay, if we are going to build our own message queue, how we're going to do that? And we called it, let's do it directly. So that means, in this case, let's just use HTTPS connections and transfer the messages over that. So we ended up with a in-memory store of messages and transfer everything. Now you can imagine that in memory, what happens if that machine goes down or crashes? We said we don't care, we just resynchronize. Our shard synchronization protocol is that efficient that we can do that without a lot of time and overhead, so let's not worry about it that much. So the picture, remember the initial picture that also had Kafka. Now I have the different roles of worker and master in there as well, and we ended up sending everything over this master-to-master connection. We now have that completely up and running, and it's a heck of a lot simpler. We can now again use Windows, we can use Mac, and everything is in like a single Go binary again, and it's a lot nicer. So, what did we gain? A lot less moving parts, no more Kafka, no more Zookeeper, HTTPS for everything, so no different tools needed to debug your Kafka stuff, and we can run everywhere again. So that was really nice. So some conclusions of this. I need to speed it up a little bit, I see. Yes, it was an interesting project. It was fast and furious, and we were late, yes. But in the end, it was not that bad. And choosing Go was actually the right thing to do in this case. I really believe that we would not have even had a chance if we had done it in any other way. And again, I have to say a very big thank you to our lead customer, because that was absolutely amazing. Good. I'm going to give a switch to a slightly different topic. I see the time, so I'm going to rush through that. What happened this year? We find Kubernetes everywhere. Even on conferences like this, you have a lot of talks about Kubernetes, and our customers are asking for it. What were the deployment options that we have until, let's say, now? You could run something very low level with systemd on your machine. We have an easier tool, which is called a starter, and we have a managed cluster in DCOS or Mesos. And obviously, Kubernetes is missing from there. So we said, okay, let's do Kubernetes as well. It's hot, it seems to be winning. Customers are asking for it, but they don't always know exactly why, to be honest. And there are actually very good reasons why you want to do that. Let's be honest about that. And so we started looking at how do we want to do it. I will go very quickly over this. The typical way of doing stateful things in Kubernetes is with a stateful set, but we cannot do that. And the reason we cannot do that is that a database has very specific rules, what to do in case of upgrades, what to do in case of things failure, and we just cannot model that in stateful sets. And we also don't want to ask our customers to write, let's say, books of YAML code to get this all up and running. So we did stateful sets, and we gone for something simpler, and that simple is looking like this in the white box. That's everything that you write in order to get your to specify your cluster in Kubernetes. And all of this is very standard Kubernetes stuff, and the only thing that's special here is, okay, I want the cluster. And if you say single there, you get a single instance, and in this case, it's a cluster. And that is a custom resource, and the custom resource is a very nice feature of Kubernetes that we now heavily use. And to deploy that, you can easily do a kubectl apply of that file, and your cluster is built. If you want to scale, no problem, just raise a number like I did here and say, I want 7 DB servers instead of the default 3 ones. Upgrading, also no problem, just specify the new version of the new image that you want. Well, I'll skip the features. You just have to play with it. Everything is on our website. There's even a getting started guide already. What is the current status of this Kubernetes operator? The deployment itself, so running your cluster, we say it's not ready for production, and we have reasons to say that, and the most important reason is we haven't tested all of it on all Kubernetes offerings yet, but you should try it anyway. And just have fun with it. Let us know what you think. Let us know what goes wrong, if any. And we are currently in the process of supporting data center to data center in the same format as well. Good. I wanted to give a demo, but I don't think that we have a lot of time. Is that correct?
Well,
we can try.
10 minutes.
Okay.
I don't know how much time you need.
Well, it will probably take a little bit more than we have, but that's just, this is, you may recognize this white box that I just showed you. This is slightly more. The reason it's slightly more is that this is a thing that I deployed in a data center that is running on a couple of machines in Paris. And well, we want a cluster. It has to use a certain image. We have to we specify some things for TLS, so we get the right certificates, and we specify where it's available. And this whole block here, I don't know if you can see it, but that is about data center to data center synchronization. So that means turn on data center to data center synchronization for that cluster. And what I'm now going to try at least, let's see if we can get it working. Do I have the right thing here? Probably. kubectl get pods. Now let's see if the Wi-Fi is still working. Yes. So here I have a view of the pods that I have in a cluster that is running in Amsterdam. I already have one running in Paris, and now I'm going to run a cluster. Let's see, Amsterdam cluster. I'm just going to do a kubectl apply. And now hopefully we'll start seeing this thing come up in Amsterdam. There we go. I don't know, is it a little bit visible in the back? Don't care about the details. But the very first thing that it starts doing is it needs to know the exact version of ArangoDB for a certain Docker image. We specify a Docker image, and of course you can say in the tag of your Docker image, this is version 3 something, and then it's actually 3.2 something. So we first run a pod that actually runs the database. We can ask it, give me your exact version, and then we start the rest. And what you see happening now is that there are a couple of pods are being started, and they are doing some initialization. We have a couple of agents, a couple of coordinators, and in the bottom, but you don't see that, we also have what we call a couple of primaries. These are the database servers. Now I prepared some commands to actually make it a little bit easier for myself. Let's see. What I'm now doing is just fetching the TLS CA certificate that was automatically created. So when I try to open the web UI in my browser, I should be able to see a proper database web UI without HTTPS warnings. So let's see what we have here. We already have our database running, which is running in Paris. So let's try to log in there. Oops, yes, there we go. And in a different tab, let's see if it's already there. Yes, there we go. We have something running in Amsterdam now. This is just a very blank database. You can see it has 3 database coordinators and 3 DB servers. Everything is running fine, and I don't have any data in it yet. For example, if I now create a collection here, I can just add a collection. Let's give it 2 shards and say there's a collection. And if I go to the collection on the other side, nothing happens. And the reason nothing happens is that I didn't tell it yet that it should start synchronizing. So let's see if we can get that running as well. I'm using some aliases because I'm a bit lazy in terms of typing. What I now deployed in the cluster looks like this. It is a different custom resource, and it says I want to replicate data from a certain source to a certain destination, and this is what you have to do with TLS and authentication and all that stuff. And now I will run some watches of the status in both data centers. And you can see that, I should have started this before, but you can already see that it tries to get everything up and running, and this is going to take some time to do the initial state. But you can see here, for example, for all the shards that are in the system, remember that I created a collection already, and that's what starts running now. And if we go back to the second database and refresh it, we can see that the full collection is now also in Amsterdam. And maybe you can see it in the back, but the button to add a collection is actually grayed out. That means that now the cluster in Amsterdam is marked read-only. So you cannot write to it, but you can read from it. And at some point, we should be able to put some data in it. But I think I'm going to skip that because I'm really out of time. No? Okay. Okay, no, very good. Then we try that. Oops, wrong one. Let's insert something into our foo collection and run it. If I now go to the collection which is running in Paris, I can see that the information is there. And now let's see if the thing is already running. Yes, so if we go in here, we can now see that in Amsterdam the data is there as well. Good, that's everything that I wanted to show you for the demo. Just have fun with it, try it out, and if you want to reach us, please do so. There are some closing words. Just go have fun with ArangoDB, try it out, and all the information is in here. Thank you very much for your attention.